Great afternoon, ladies and gentlemen. Great to see you. Please be on page 12, and we're going to get started with 8.1b lesson, rotations. You're going to need about 3 pieces of patty paper today, a compass, and hopefully 1 or 2 colors, along with your pencil. So let's take a look. We talked about rotations last time in reflections. So on the grid below, triangle ABC has been rotated with the center of rotation at the origin O. This process was repeated several times to create all of the images shown. Using your tracing paper, your patty paper, trace triangle ABC You may want to label your vertices and your X and Y axis. And holding your pencil as an anchor, rotate your triangle counterclockwise, that's clockwise, counterclockwise to see how all of the images are created. There's a 90 degrees. Or I guess that would have been, this would be 90 degrees. Interesting. What I'd like you to do is label the corresponding vertices on angle C of all the images for triangle ABC. So if I look and rotate, all of these inside vertices are going to be C. Technically it would be C prime, double prime, triple prime, quadruple prime, and so on, but we'll just call them C. What I'd like you to do is I'd like you to use your compass, and how a compass works is this center metal part is always on the center of your circle, and then you line up either one of the dots on the orange part, or if it's a very tiny circle with a small radius, use one of the holes in the center part to draw your circle. So make sure this is on the center. I'm going to line up with one of my C's. It seems like this is a pretty good one. And rotate around. Your binder may get in the way. You may have to take out this piece of paper and take a look. What's the relationship between angle C and the center of rotation O? What's the relationship between angle C and all of its images to the center of rotation O? Did you say they're equidistant? Well, that's right. Does this relationship to the center of rotation hold true for the corresponding vertices A and its images and B and its images? You're right again, it will. So if I take a look, angle C and its images are equidistant from the center of rotation O. This is also true for angle A and its images and angle B with its images. What's important to note is that corresponding vertices lie on the same circle, whose center is the center of rotation. Remember, the definition of a circle is all the set of points equidistant from the center point C. In this case, our center point is O. If you take your compass and have the same center of rotation at the origin, and you use vertex A and its corresponding vertices, you will notice we have another circle. These two circles are called concentric. Concentric circles mean they have the same center. It doesn't mean they're inside each other. These blue two circles are not concentric. They have two different centers. I also want you to know, so that all these circles are concentric circles, they have the same center. So taking a look back at our rotations, taking a look back at our rotations, if a full circle has 360 degrees, how many degrees is each one of these rotations? Give you a moment to think about it. How many degrees is just one of these rotations from one figure to the next? That's right, it's 30 degrees. 30 degrees. We have 12 triangles and 360 degrees in a circle, and 360 divided by 12 is 30. 30 degrees each. Let's turn the page. Taking a look at the next page, I want you to use your patty paper again. And you can use the same piece of patty paper, just not to be wasteful. And you can use the same XY and just trace triangle ABC. And notice ABC, our pre-image, we're going to call it 1. So we've modified this slightly so the same triangle won't work. But notice we're only rotating in increments of 90 degrees. We're only rotating in increments of 90 degrees. And because we're going to follow the numbers 1, 2, 3, 4, this direction that we're rotating is, that's right, it's clockwise. So verify using tracing paper that the descriptions of the rotations are accurate. So I'm going to start on my pre-image, use my pencil at my center of rotation, and go 90 degrees. The way I know it's 90 degrees is because the X and Y axes should line up again with my cross in the center. ABC, ABC, ABC. Very nice. I want to know the rotation from figure 1 to figure 4. It's been described as a rotation of 90 degrees counterclockwise. However, if I need to go clockwise to get to figure 4, how many degrees is that? Let's count. 1 group of 90, 2 groups of 90, 3 groups of 90. So how many degrees is that? That's right. It's a 270 degrees clockwise rotation. So whenever I say 270 degrees clockwise rotation, make sure to note that that is equivalent to 90 degrees counterclockwise. Now let's take a look and investigate our slopes. And we're going to focus just on figure 1 and figure 2. Looking at figure 1, what is the slope of segment AB? That's right, 2/3. Now go to figure 2. What's the slope of A prime, B prime? Yes, it's decreasing, -3/2. Go back to figure 1. What's the slope of segment BC? Yes, -1. And segment B prime, C prime? +1. Go back to figure 1. What's the slope of segment AC? 0. And segment A prime, C prime? Undefined. Great. Use the slopes from the previous question to determine the relationship between corresponding segments in a 90-degree rotation. What do you notice about the numbers? What do you notice about the numbers? The numbers, the slopes are, you're right, opposite reciprocals. If the slopes are opposite reciprocals, that means that the corresponding segments are perpendicular. The lines are perpendicular. Remember, this is the symbol for perpendicular. It's like an upside down capital T. The lines are perpendicular. The slopes of corresponding segments are opposite reciprocals. So if I ask you to prove if something is a 90-degree rotation, you can always investigate the slopes. Taking a look, describe what happens in a 180-degree rotation of a figure. What is the relationship of corresponding segments? So if I go 180 degrees from figure ABCD, I go 2 groups of 90. So I'm going to be at figure 3. Oh, what if I go counterclockwise? I still end up at figure 3. So what happens in a 180-degree rotation of a figure? Well, if I look at segment AC and segment A double prime C double prime, and I look at segment BC and segment B double prime C double prime, I'm noticing they have the same slopes. What do you know about lines that have the same slopes? They're either two things. They're either going to be the same line, if they also have the same y-intercept, or they are just parallel. So corresponding segments of a 180-degree rotation are parallel or the same line because they have the same slope. Parallel or the same line because they have the same slope. Wonderful. Let's continue. I'd like you to rotate PQ 90 degrees counterclockwise with the center of rotation at the origin and label the image. There's a lot of important information in these directions. When I'm looking at these directions, something I really want to notice is the direction of my rotation, the degree of my rotation, and the center of rotation. So the center of rotation is the origin. So again, I'm going to grab my patty paper. I'm going to make sure I can tell where my vertices are. And this one's P and this one's Q. And I need to go counterclockwise, opposite direction of a clock, 90 degrees. When I do that, I end up at -6, 2 and -2, 8. -2, 8 and -6, 2. It's important to notice what your new coordinates are, and you can use your compass as a straight edge. Oh, I forgot to label my corresponding vertices. Is this one P prime or is it Q prime? That's right, it's P prime. And this one is Q prime. This is the image I came from the pre-image. So taking a look here, use slope to verify that your image is in fact a 90-degree rotation. How can I use slope to make sure something's a 90-degree rotation? That's right, corresponding segments, the slopes, should be perpendicular. So let's investigate the slope of segment PQ. The slope of segment PQ is, you're right, -2/3. And the slope of segment P prime Q prime is, thank goodness, it's 3/2. So we can say yes. This is a 90-degree rotation about the origin. That's important. We have to say it's about the origin because the slopes are what? They are opposite reciprocals. Nice. So now what I'd like you to do is we're going to use the distance formula to verify that point P and corresponding point P prime are equidistant from the center of rotation. Remember, when we are dealing with rotations, we should have corresponding vertices lying on the same circle, and all the circles should be concentric, sharing the center of rotation as their center. So to use the distance formula, I need to find the distance of PO, and I need to find the distance of P prime O. Go ahead and find the distance of those two coordinates. Remember, P is 2, 6, and O is the origin 0, 0. And the distance formula is the square root of the change in y being squared plus the change in x being squared. And we're going to be able to substitute in those numbers. 6 minus 0 is 6. 2 minus 0 is 2. 6 squared is 36. 2 squared is 4. 36 plus 4 is radical 40. But no one leaves their answers in unsimplified radical form. What's a perfect square that goes into 40? 4. 4 times 10. Pull out the 4, it becomes a 2. 2 radical 10. So in order to prove that they're equidistant, I